let's suppose that we have a function. We'll call it f. So we're gonna let our function be called f. Okay, so that's the name of our function that we're gonna be working with. Now we're gonna let y, the height value, be equal to the function evaluated at any x value. So when we plug in x, we get y out. So f describes the relationship between x and y. Now what we want to do is we want to take that function, okay, which can look like anything, okay, but I'm just going to sketch out some curve of a function. Okay, so here's our axis system, and we'll sketch this guy out here in blue. That way it matches your textbook. So we've got some function that looks something like this. Okay. And now let's say that we want to find some tangent value at a point. So let's pick a point, a random point, an arbitrary point. And we'll call this point P. Now, that point has a line that runs through the points and is tangent to that curve. So the point P is on this red line. The red line runs just like this, and you can think about it as touching the curve in this vicinity just once. Okay, so right around this little area, this red line touches this blue curve at P. Now, the curve follows, so this curve follows this line, or this line follows this curve very close to P, and that's the idea of the tangent. Now, that's a really informal definition, so we'll get something that's a little bit more precise in just a little bit. But for right now, for our story, we want to determine what's the equation of this guy. Okay, so we want the equation of the red line, which is the tangent line. So here's what we're going to note. We're going to say that P has some x value. Okay, so x is this axis, right? F of x is this axis up here. And so we don't know what P's x value is, so let's just call it something. We'll give it a variable name. So let's call it A. So if P is at A over, and P also falls on this blue line, then it must be at a height of f of A. Right? So I mean, if you want to find out an ordered pair for P, if you plug in A into the function, because P is on the line, then your x value is A, and your y value is the function evaluated at A. So here's what we have right now. We want the equation of the tangent line. We have one point, which in this case is P. But therein lies the problem. We only have one single point. So how do we come up with a tangent line with just one point? Here's the trick. And this is what we're going to do for the first first part of the semester. Is we are going to take that same blue line. Let me redraw it. So there's f of x. Here's our point P. Again, it's over A, and its height value is f at A. Now, to get an estimate for this red line, this red tangent line, what we're going to do is we're going to pick another point. that's not on the red line, but on the blue line. Maybe right here. Let's call that Q. Now Q also has an x value and a y value, but we know what they are. Okay, so let's say Q is at a length of b over for its, so this length right here is b, that's its x value. Its y value, its height, is f of b. So now what we're going to do is we're going to use the line containing P and Q as an estimate for the red line. So the green line is an estimate for the red line. The green line is called a secant line. So here's what we're going to do. We're going to calculate the equation of the green line. And so the slope of the green line, the slope is given by the change in the y values divided by the change in the x values. So our slope is going to be f at b minus f at a over b minus a. So this right here is an estimate for the slope of the red line, which is the tangent line. Now what we can do is if we take Q and we move it a little bit closer to P, we're going to get a better estimate. And if we move it even closer to P, we'll get an even better estimate. And so the idea is we want to take Q and squish it towards P. And if we do that, we're going to get a better and better estimate for the slope of the red line. And once we have the slope of the red line, we're good to go, because we already know one of the points on the line, and therefore we can get the equation of the tangent line. That's the idea, and that's what we're going to work on here in some exercises that you see below. So we'll work on exercise number 1 for estimating a tangent line, and we'll use some real numbers. We'll plug them in there, we'll get some sketches out, and we'll try to determine or try to estimate the actual tangent line.